That was Andrei from Slovenia joining us today. If you want to learn a little bit more about cloud security, you can send him a message throughout our platform. I already said that you can arrange meetings, send messages, you can talk with your partners throughout all the exhibition halls we have. This is the main hall. In the main hall, we have more keynote speakers coming up. One is already with us now because it's his time. 30 plus years of experience. Well, that's one me, ladies and gentlemen. Currently technology expert and leading industrial camera manufacturer, 360 vision technology. So he likes cameras, radar, and thermal detection technologies. So let's tease him and tease the professionals as well. Tony, can you hear me?
Yes, I can hear you. Very pleased to hear you, and good afternoon to you all.
Nice to have you with us. Tony Holloway is with us, ladies and gentlemen. His presentation is prepared, wrapped up, and we're going to see if it's on screen right now. So can we see the sharing, Tony?
There we are. Let's see if that gets to you.
Well, we see everything. We hear you loud and clear, and I know that your cameras already have me from the stadium, so I'm going down.
Thank you very much. Well, for this presentation, I'll actually just turn off my video because there is a lot of video content to show you, and because of bandwidth limitations, I want to make sure you get the best experience. So I'll disappear and reappear at the end. So let's jump into our presentation with the agenda for this afternoon. So we're looking at large area surveillance. Now, when we're talking about large area surveillance, we're going to specify the sort of size we're going to be looking at, and we're going to look at a couple of technology solutions. They are particular radar technology and thermal technology, but specifically for those larger areas. We're going to look at some key features. We're going to talk about the limitations and considerations for those technologies within these areas and examples of the performance all the way to a Q&A at the end. So without any further ado, let's go straight into large area surveillance applications. What is a large area? So we're really talking about a security requirement that has identified that we need some form of intruder detection, surveillance detection over a very large area. So more than a fence line or just a building where we've got some selected cameras and detection equipment, we're looking at an area of expanse. So typically, possibly an airport area, very open runway and areas leading to a runway, very long open fence lines in some cases. It could be borders where we're looking within and without a particular area, people approaching to a fence line rather than along a fence line. It could be agriculture areas, typically maybe fish farming, for example, where it's difficult to actually put structures at the location where you're looking to protect your assets. And that's one of the key things here about this technology. We're looking at being able to place a technology perhaps in a single position, not necessarily multiple places, and still capture a very wide area. So the first one in to see here will be radar technology. And we're looking at radar technology from the basic principles. We're going to look at some applications for this particular technology because it can actually be quite niche as well. And then that integrated solution, bringing it together, the video and the radar into a single package. So what is radar? So radar actually stands for radio detection and ranging. And what that's all about is using radio waves to actually detect the presence of an object and see how far away it is and see what speed it's perhaps traveling at. So the first part of this is just look at those basic principles. I always feel that it's important to understand the principles of the technology, and then we can understand the best place to actually employ that to meet our operational requirements. So here we have a radar sending out a beam of energy, in this example, a pulse of energy into the sky. And if there's any object that happens to be in the way, that radio energy is going to reflect off that object and come back to the antenna, or a little piece of that information is going to. Now, because we know how long it takes to actually transmit that radio energy through the atmosphere, we can measure the amount of time, therefore, it takes, and that gives us an idea of how far away the object may be. We can also get an idea of how large the object may be. In the simple principle that it's a small object, you may get a very small amount of data reflected, whereas for a large object, you'll get a larger amount of data reflected. So quite simple in its performance. The amount of information we have coming back once we've sent our beam of energy out could give us an indication of the size of the object. Now, the final bit would be the bearing. And of course, you've seen radars, I'm sure, at airports, other places, they're rotating. So sending out that beam of energy at a different bearing gives us an idea of the geographical location of a target, the distance, and we can work out speed as well. So here's an example screen of a radar itself, the output. And as you can see here, we've got a clutter span we see on the screen here, radar right in the very center, and we see some lighter areas, some targets that have actually been hit by the radar. Let's put that radar output in context. And what we're looking at here is an urban area, radar right in the middle, lots of houses, etc. This is in a park area. If I just lighten up the radar output, we can see here that radar in the center, those darker areas around the edge with trees. So they're the reflections we're actually getting off objects. And of course, everything moving in there, that would also get a reflection as well for the radar. Now, there's a lot to radar, of course, way more than we can do in the slot today. And we've got thermal to talk about as well. But just signposting there some other areas where radar technology differs in its way and how the signals are actually produced, how it's actually used also in sophistication. I'm sure you know radar all the way up to military specifications as well and other applications. So that potentially for another time. Let's move on here and talk very specifically about security application, the benefits of radar, and what we're looking at, of course, is a detection technology that works essentially in all weathers. It operates when it's light, it operates when it's dark, it doesn't get affected by the sun, etc. Very low power as well, and can cover a very large area. So a little video example here, hopefully this will come through to you. And what we're seeing here is a radar trigger. It then pushes the camera around to actually lock on to the target that has caused that trigger. The radar is constantly monitoring that target, individual here walking along, and it tells the camera to lock on to that target. And as you can see, it's actually tracking that person. That is the whole principle here of the radar technology, detecting an individual and moving on from there. So what we now need to consider is the situation where we can apply radar, because it's important to know that a radar can only really see as you see in the sort of frequencies we're talking about here. So terrain, really important. If you've got hills, etc., the radar energy will go into the hill, it won't go behind the hill, the same as it won't go into valleys either. So important in terms of obstacles that could be in the way of a radar when it's deployed. The other thing to be wary of is some of those unwanted alarms you may have. Trees that will move in the wind, they will produce clutter that will come back to the radar, and also long grass as well could produce clutter. That would reduce the sensitivity of the application. So consider areas that you can't detect really using radar accurately would be in areas that are constantly moving with a lot of clutter that is there. Very good for open spaces. Something else to consider, and this particular one we see here, tracking some individuals in this still frame of video. Large buildings, metal objects do cause reflection and more clutter. So you could have a situation where you have what was known as reflection. And reflection comes about if we look at this plan view, if the radar was the yellow dot we see on the screen, and as we go up in the green direction, there's our target. But there's also another path to that target once the radar has actually moved. The red line, which is reflecting off the building, also to the target, could give us a misreading and make the radar think the target is inside the building. Naturally, that would be masked off in a solution, so it would not cause a problem, but it's something to be mindful of when actually using the radar. What we also have here is the placement of the radar in terms of a fence line. As I said, radar can see as you see. So if you can see through the fence line, it will be able to see straight through the fence lines. But notice on the left hand side, that area of an oblique view, we can't see through this fence line on this image. And the radar could also be blocked from that, creating a blind spot behind that fence line. So typically the radar would need to be backed off from the fence line or exactly on top of the fence line so it could see clearly down both sides. And the final one to picture on here with some examples, the severe weather. When real bad weather's in play, then of course it is possible that it could actually interfere with the range capability of the radar. However, we've got a lovely example here. If you can see you this video where we're showing the actual radar in the snow. Fortunate to actually have an opportunity to capture some footage here. And as you can see, the radar is tracking this particular green vehicle that's coming down the road on this snowy day on this construction site. On the right-hand side of that image, you can just see the overlay of the radar output and the red crosses that are appearing, which are the targets as we see them on screen. So what we have in this technology is the ability to bring it together as a package, so we can have a radar and the visual verification using the CCTV camera. So here's an example. This is a Predator radar from 360 Vision, which is taking radar technology, which can be different models, into this surveillance package that brings those two things together for that wide area capability. This particular model, 200-meter range, so that's a good range for detecting people, individuals. That is 125,000 square meters of coverage, and it can detect multiple objects at the same time, and you can decide which of those targets, those objects it wishes to follow. You can add in many other objects into here in terms of capability on the surveillance, long range lighting. We can bring in thermal, etc., which I'm going to talk about in a second. So lots of capability. But in terms of those images, of course, you've got the radar detecting. He wants to push the camera around to those targets. 200-meter range, that's the sort of size people are going to look in the daytime on a muggy day. 200 meters to those two individuals, 40% of screen height, certainly enough in terms of HD resolution to be able to identify those individuals. At nighttime, support illumination, really beneficial. So here we have a dark area in the middle of the night. We can zoom into our target, range up to 200 meters. And incidentally, this is using a no-glow IR technology. That's the 940 nanometer technology, so easy all the way up to 200 meters and beyond. A little closer into our target, and we can even turn the lights off just to show how dark it actually was at this location. And we'll just bring them back on again. You can see nothing at all without the support illumination. You also have the benefit in terms of the integrated package of having white light. So this is the image without any light on at all, forced into color. We turn that white light on, we now have color images, and zooming into our test target, we get that detail coming back from the target. Again, all integrated into the radar covering this large area. And the final one, just to tease on here, color image at night, so ambient light, but not immediate to know where the item is, where the radar has actually found that particular target, but the thermal signature from the camera really actually enhances that there. So final one really on the radar is this application. We're showing it here on a vessel on the River Thames, nice large open space, large area for detection. And some still frames here from the video. Top right hand corner, we're showing the actual Predator radar technology detecting this vessel, which is a cruiser coming down the River Thames, and in the middle of the top there we can see the radar output that is being produced, and the blue line is showing our target. And I've actually moved this video on to various still frames as we've taken here. We can see it tracks this particular target, and we've used it to stay on the primary target. So they're telling the radar, push the camera just on your first target, but monitor everything else in the area as well. And at this point, when that City Cruises vessel actually leaves the detection range, the 200 meters, the radar then chooses the next nearest target to the camera. In this case, it's a blue rib, which is navigating its way up the Thames. You can see the yellow wiggle on the radar output at the top of the screen, and it follows all the way and continues out. So an idea there of the operation in terms of radar, large open space integrated into video technology. Now let's take a look at some thermal application. The other thing we wanted to talk about is the use of thermal and how we're going to do that in large area surveillance. So we start with the example of why thermal, if we didn't already know. In this particular example, we are looking across a large river space, happens to be Loch Ness in Scotland, and during the day we can have superb full color HD images all the way across that lock. At night time, we've got some good images as well with a little bit of IR support illumination. And when we zoom in to look into the water, it's rather dark, it's rather black. And the reason is there isn't sufficient IR illumination or anything out there to actually reflect back to the camera. When we introduce the thermal, what we're actually seeing here is almost like a daytime image. So the thermal technology really enhancing the surveillance capability. The thermal technology, of course, is in that spectrum outside of the visual thermal spectrum, if you like. On the right hand side here, you can see what the thermal image is delivering compared with what's on the left. But let's look at thermal a little bit more closely, because it is quite important that you think, well, it can detect in great areas and have this ability on detecting heat sources, but there are some limitations there as well. So on the right hand side of the screen, we see the front of a vehicle. What's missing? The registration plate on the front of the vehicle. It's there, but the thermal camera, of course, can't read it. It also can't see through the glass inside the car, and it can't see through any of the plastics either. So a little bit of comparison here on screen, which is a piece we do in our webinars that we put out, is essentially showing the thermal technology through various different types of materials. So there is myself, and you can see straight away I'm wearing glasses, and the thermal can't see through the glasses. It looks at the thermal on the front there. If I'm now holding up a piece of hard plastic, which is completely transparent to the human eye, yet the thermal camera can't see through it, sees a reflection actually off it. Similar with tin foil, it's reflecting, not necessarily the temperature on it. Paper, of course, you can't read paper with a thermal camera, but interestingly, my hand behind the paper, you can see the heat signature of my actual fingers behind the paper actually going through to the surface on the other side. However, film, such as a cling film, for example, wrap film, you can see straight through that, holding up a piece of cling film in front of the camera there, which also makes it quite interesting when you have a plastic bag of water. Really important here, water obviously can't see through it at all. You're just seeing some surface temperature, but you can see through the plastic bag that it's actually handled within. So a lot of to do there in terms of thermal technology. So just some pointers, again, way too much to talk about in our speech today. However, there are lots of further learning that can be done. I think I've already mentioned once that we do some other sessions that delve into the deeper areas of thermal technology. But we're going to touch a little bit on this because it's important we do have an understanding, and particularly when we look at the wavelength in use, so visible light, that's it at the top there. And as the frequency decreases, we get all the way down to the various different wavelengths, including long wave IR. So in terms of thermal, we're interested in long wave. We're interested in long wave for security because the human body actually radiates at 10 microns, as we see on screen there. So very good using that technology to actually pick up individuals, which in the majority of cases is what we're interested in. The other thing to note here in terms of that particular wavelength is weather. We've already seen that water can obviously stop thermal technology. So areas where very high moisture content, heavy raining, etc., can actually limit the capability of thermal. Of course, if you manage as an individual to match yourself to the background temperature, you essentially could potentially disappear. So one other thing to actually talk about when we talk about thermal is the fact that it are controlled in terms of a technology under dual use, essentially because high-powered thermal technology can be used for military purposes. In the security world, we don't need that level of capability, but it does mean the technology is operating at 9 hertz, which is not necessarily what you may deem as real time. So just a few images per second rather than 25, 30 images per second. A couple of examples of this on screen. Don't know if these will actually come through nicely, but the right hand side image there, which is just playing, shows a 25 images per second color image of from a camera, and we compare that to the thermal on the left hand side, which is a little bit more stepping. So still real-time image, but it's actually stepping rather on the screen. That's really the two differences. Doesn't make a huge difference in terms of a security application, because everything we need is actually there for detecting individuals. And when it comes to detecting, the beauty of thermal is we only need a few pixels on target to be able to actually say that's definitely an individual, and only a few more to actually get to recognize what an individual may be. That means we can get some really super long range using thermal technology. So an example here, very narrow field of view, we can see a person 2.5 kilometers from the actual camera. So you can see a very large area we could actually cover with multiple thermal cameras. Here's an example piece of footage looking a great distance indeed, but appreciate this is probably a bit small on your screens to see any of the detail that's in there. This is using a 35mm lens on a 640 resolution thermal camera. Now, if we just pop to some still images of this, so slightly larger, middle of the screen here, we're looking at 1 kilometer away. We're at a point where we can actually detect individuals. So you can see here, we're looking at a beach scene, and we're going to look very closely in at that particular point. That's the 1 kilometer. And if I just large that out, you can then see in the bottom right hand corner, right in the center there, those little white dots, individual people, just a few pixels on target at that 1 kilometer, enough to detect there are people there. A little bit closer, so to recognize 250 meters, and we have the same sort of in the center of the screen there. We have some individuals. I'll make it a little bit larger on screen for you, and you can clearly see they're people. You can see what they're up to, and we can also differentiate between person on the left looks like a child, person on the right is an adult. So we're recognizing what these actually are, as opposed to being a vehicle or something rather different. So for security application, it does make thermal absolutely ideal. It brings in some other capability as well, because on the right hand side here we're seeing a thermal on the left-hand side, sorry, we're seeing a thermal image. On the right, we have the visual image. On the visual image, you can see a very bright light. You can't see that on the thermal because it has no heat source whatsoever between these two images on that fence line application. We have here thermal image seeing right through smoke. So on the left-hand side, doesn't you see the smoke at all? On the right, it's actually really affecting the image on the visual camera. And this final one here, just looking at some rain. So on this particular application, we have on the right, the rain is not in place. We can see the reflection on this actual car. In the front of the car, it's quite bright because the sun's come out. Whereas on the left, where it's raining, it's dulled off the image, it's dulled off the reflection. So you can see some of the impact there on rain in terms of a thermal image. Of course, what we're really showing here is the thermal on its own can't really provide evidential information. It is that combination and bringing it in with the visual camera. So it's mixing those two technologies together. And as you can imagine, from 360 vision point of view, we have a lot of capability in the products we produce in integrating these technologies together in the one unit. And this includes really taking those various types of thermal images, and whether you're overlaying color onto those to actually make them a lot more prominent in terms of picking out individuals. One in particular being ice and fire does mean that you're picking at targets. Again, here's a target that we're going to see here over 1 kilometer away. In the middle of the screen, red dots actually highlighting how far away that actually is. We can't see without the visual camera. Here's the visual camera on screen. We can therefore zoom in and actually pick out the detail of what is creating that heat source. In this case, it happens to be queuing traffic at that distance of 1.25 kilometers from the camera. A little bit closer to where the camera is here, we have an industrial site. Because we've got the visual camera over this area, we can zoom in and read registration plates 150 meters away from the camera here. And at night, ambient light, color images, no trouble whatsoever. The thermal is highlighting for us, of course, that we can actually see an individual running along that red, really making them stand out along with the vehicles in the actual background. So the key combination there of bringing those two things together. So with the thermal and the large area surveillance, let's look at the situation here where we're going, well, okay, I've got a very large area and I wish to as to monitor and automate what is actually happening, similar to the radar, if you like. So we're taking multiple thermal cameras and stitching all the images together. So in taking these and bringing them together, we can now treat this as one very large thermal image that has tremendous range. In this particular application, this is Tower Bridge on the River Thames. So we'll see if we can play this small piece of video for you here. And what you're seeing at the top of the screen is the thermal images connected together, and there's a lot of colored markings on those because we've identified everything that's moving in this scene. We're particularly interested in anything that goes below the bridge. It's a security application. Anything that's under the bridge, we want to take a look at it with the visual camera, 24/7 operation. So running this piece of video, what you'll see here, the top left is showing a boat disappearing to the left-hand side. The top right, we've highlighted that there is a vessel there at a quay. It's near the bottom of the actual bridge. So we've just seen that with the actual visual camera. We've gone back to actually spot the vessel that is moving away. Back to this one we can see on the right hand side, but we have a new entry in the center of the screen at the top. It's approaching at just over 300 meters. When it started to approach, it's about 250 meters. You probably just can't see it, but at this time we've now highlighted in on that police launch, which is approaching Tower Bridge. And this of course is an exercise. What this launch is actually doing, it's going to rest underneath the actual bridge itself. And at this point, we can see that the surveillance solution is monitoring everything that's happening in the area, including some individuals and vessels in the far distance that are over 1 kilometer away from the camera location. This time we're focusing the video in on the police boat, and once it's finished it's loitering under that area as part of this particular test, then the camera will go wide, come off that and go and pick the next particular subject. So this is all configurable, so get a large area surveillance solution, quite possible there, combining the thermal technology in with the visual to be able to give you that visual identification, and the same inside the thermal. So believe it or not, already we've burnt up our 25-minute slot here, so I think we should probably round up quickly into a quick summary of what we were looking at there, because we looked at the radar technology, we looked at the thermal technology, but as I always underline in any of these things, it actually starts with understanding the capability and the limitations of that technology and how that applies to your operational requirement, which is the bit, of course, that works out what solution, what threats are actually in place, what is required for any particular application. And those two technologies are very good for wide area surveillance. So I really hope that was particularly useful. We teased in there some other things with respect to integrating those and video analytics on top of it as well. So I best open it quick to some questions, if there is some.
Thank you, Tony, for being with us. So no more hiding, ladies and gentlemen. We see you all the time. Nice to have you with us. It was a great presentation. Something which we learned was like, wow. And the question first goes in the privacy sector. So can you tell us, how do you deal with privacy concerns, such as with the use of technology that actually allows the police to see inside the homes? Is it legislatively okay, or?
Oh, well, that's very interesting. I mean, honing it particularly on the two technologies I was actually talking about here, which is radar technology and also thermal technology. Something we straight from, of course, radar, not with inside the home, doesn't go through buildings, doesn't go through windows, so of course that can't make its way in. And thermal technology isn't very good at actually providing evidential information. You can't identify someone from that thermal technology. So sort of answering that in that particular sphere, that's where thermal is very useful in monitoring what's happening in many places without actually giving identification. You need that support of the visual side of things, of course, to be able to provide appropriate surveillance information that will identify individuals. Should that be the case? And of course, within the law.
That's nice. So we see the suspects, we do boo when they went out, we say, haha, you're on radar, now it's okay. Thank you for that one. And next one also came in. How will these systems integrate with current physical security solutions such as VMS, physical security information management systems like PSIM and or access control systems, ACS? Can we combine them all?
Absolutely, that is the case, particularly if I could talk of most solutions on the market, but including those from 360 Vision Technology. OnViv is that video interface that is often talked about. So as far as a video is concerned, be it from the thermal point of view in an IP sphere and the visual sphere, the interface is actually the same in terms of bringing those into the widest range of video management systems. But it's also because the alarm capability as well. So if you've got a video analytic that's taking that detail and generating alarms, the same applies to the radar as well. The video from an OnViv platform, although SDKs are also available, the ability to take alarms from that when it's triggered, which could be as simple as a contact closure, multiple contacts for multiple zones, or serial data as well. So there are ways of actually delivering alarm information or indication that alarms appeared, including the ability to take the output from the radar and perhaps show it as a web page within inside the video management system. So lots of ways of plugging that in and really enhancing any existing system that may be there as well.
That's always nice to hear. Great product, integrated with everything you need for huge security. Thank you so much, Tony, for being with us. You were on time, you presented us great stuff, and hope to meet you in person in the future when COVID stops.
Thank you very much indeed, and the same to you, and enjoy the rest of the show.
Thank you so much. There was Tony here in the main hall. Of course, the side events start quite soon. You can check it throughout our platform. You can always use platform for communicating P2P. You can ask questions, you can send messages, arrange meetings. So in a few moments, we give you a break. This is a virtual summit, but sometimes you really need a break to just recover your eyes for a bit, and we carry on with our program here in main hall in about 10 minutes. So see you in about 10 minutes. Stay with us.